right, 6.1. We're talking about relations and functions. So ordered pairs can be used to show both inputs and outputs. So inputs are your x values. Outputs are your y values of your coordinate points. Okay, so inputs are your x values, outputs are your y values. If you're thinking about science, you've probably heard inputs and outputs before. In terms of the input is your independent variable, and your output is your dependent variable. It's the one that depends on the other one. If you haven't heard those terms before, that's just more terminology that means the same thing. So those are synonyms with each other. So what is a relation? A relation just shows how the inputs relate to the outputs. So in your lives, you have lots of relations. You are a son or a daughter to somebody. You might be a brother or sister to somebody. Possibly it could be a cousin to somebody. Maybe you are an aunt or an uncle, even if some of you had older siblings, that's a possibility. You can be a friend to someone. You can be a student to your teacher, and so forth. So there's lots and lots of ways that you can be in relation with other people. So when we're talking about relations in math, though, we're talking about how the inputs relate to the outputs. And one way to do that is with an ordered pair, and that's what you're most used to seeing. But there's another thing called a mapping diagram, and it just shows your inputs compared to your outputs. So if I have this input table right here, the input-output table, it is the exact same thing as the ordered pairs listed to the left of it, because I have the input 0 that goes to 1, which means my x is 0, my y is 1. I have the x value of 1 that goes to my output of 2, which means I have the coordinate point 1, 2. My input of 2 goes to 4, which means I have the coordinate point 2, 4. So they actually represent the exact same thing. So it doesn't matter which way you're looking at it. You can always turn ordered pairs into input-output table, or you could turn input-output table into ordered pairs. So if I give you these input-output tables for A and B, you should be able to write them as coordinate points. And this shouldn't take very long because you're literally just taking the input-output and putting it as a coordinate point. So you have 1, 3, 2, 6, 3, 9, and 4, 12. That's it. That's all you're doing. Okay, on B, this one doesn't have the lines going directly across, but I can see that 0 goes to 0. So that means I have the coordinate point 0, 0. 2 goes to 1, so I have the coordinate point 2, 1. 2 also goes to 2, so that means I have the coordinate point 2, 2. And 4 goes to 3, so that means I have the coordinate point 4, 3. So always list your inputs as your x values, the first value in your coordinate point, and your outputs or your y's are the second value in your coordinate point. Okay, go ahead and try number 1 and 2 on your own. Pause the video. Once you finish them, come back and check and see how you did. All right, so let's see how you did. You should have the coordinate points 0, 12, 2, 10, 4, 8, and 6, 6. The next one, you should have the coordinate point 1, 1, 1, 2, 2, 3, and 2, 4. All right. So relations talk about how coordinate points relate to each other, how the input goes with outputs. If each input goes with only one output, then it's what we call a function. So functions, a vocab word for today. Each input only has one output, and that's key. So if we look back at our examples that we've done, A is a function because each input only has one line coming out of it going to one output. And if I look at my coordinate points, each input is different. When we look at part B, you can see that the number 2 has 2 lines coming out of it. 2 goes to both 1 and 2 goes to 2. So this one is not a function because my input of 2 has 2 different outputs. It goes to the output of 1 and the output of 2. So if any of your inputs repeat, They can't go to different outputs. So if I'd had like 2 goes to 1 and then I listed it again, it's 2 goes to 1, that's okay. That could still be a function. But because my 2 went to 2 different ones here, that's why it's not a function. So if an input shows up more than once, it has to go to the same output, or it is not a function. Okay? So look at number 1 and 2. Are those functions or not? Number 1 is yes, it is a function. Each input goes to only one output. But number 2 is not a function because 1 goes to 2 and 2 also goes to 2. So you've got 4 to try here. I want you to tell me on A, B, and on 3 and 4, I want you to tell me, are they functions or not? Pause it, come back and check and see how you did. Okay, so A is a function because each input only goes to one output. Each input only has one line coming out of it. B is not a function. It's not a function because of 0. 0 goes to 2 outputs. Okay, for number 3, it's no, not a function because of, let's see. This one's hard to see, isn't it? Yeah, this one's poorly written. Sorry. This one shows that 2 has 2 coming out of it and 4 has 2 coming out of it. This one and this one don't have lines coming out of it. Sorry if that wasn't clear. So these 2 numbers do have 2 lines coming out of it. So each input doesn't have only one output. And on number 4, yes, it is a function. Each input has exactly one output. There's only one line coming out of each of the inputs to go to one output. So in your summary, you want to summarize your mapping diagram, inputs and outputs,